Hi, I realized or discovered that I did not actually include the workbooks in the previous video that I had. So I'm doing another one just to focus on the worksheets that I've included in this week's class. Let me jump right to those. There are 3 of them, and you can do these things with Excel formulas also, but these are so much simpler and they give you stuff so much more straightforward. I recommend doing this way. What I'll do with every one of them is I will lay out some stuff here, and in each one of these worksheets, there are places that are green. Basically, those are the only places you want to put numbers into these things. If you put something in this corner right here, where I actually have square root of d4 times 1 minus d4 divided by d3, you put anything else in there and you'll screw it up. So better to open this, save this someplace, and then come back and use it again. Saved a second time to play with. This one is for proportions. Now, if you look at, remember the chart I gave you about which test to use, proportions always use z-test. Basic piece of it. What you have is, first question is what's the size of your sample? Suppose we have a sample size of 35 and a portion that has the trait. Now, you get this from your sample. For instance, and with the example I was using in the lecture, I said 65% of my students are female. So let me say, if that's my sample, and I'm trying to infer to a population, I start off with 0.65. That's my proportion that has a trait. And I want to check the confidence interval at the, says I'm going to use the 0.05 level. And I put that in and bang. Down here what I have is upper and lower bounds. What this means is if that's the proportion, if I'm comparing my proportion, well, first of all, what it means is 95% of the cases are going to fall between 0.49 and 0.81. Minimally, what I should expect is every class I have then should have a proportion somewhere between 49% and 81% female. That's what we typical. Now, if you come up with a class and you've got 35% female, if I did, for instance, for this thing, I'd be like, oh, that's unusual. That would be significant at the 0.05 level because it's outside the boundaries. And that's what this thing does. It tells you what the boundaries are, that 95% of the cases are going to fall with this proportion, with this sample size, 95% will fall in here. Let me just point out for you, I have the sample size here, 35, and it's 0.49 to 0.81. Suppose my sample size were 100. Look how much smaller my confidence interval is. It jumped from the low of 0.49 to 0.56. It dropped the upper bound from 0.81 to 0.74. Increasing the sample size reduces the size of your confidence interval. Crucial point here. I'm going to move on to Z confidence interval. Same sort of format here. Now, if you remember, the stuff I told you is you can use a Z when you know only when you know the population standard deviation. If you don't have a population standard deviation, you cannot use a Z-test. But again, suppose here what I'm saying is what was my measures here that I want to use on this? Age, for instance. Suppose I say what I have, my sample mean was 26.4. I want a 0.05 level. My sample size, and this is the place I get killed, this one is 15. The population standard deviation, well, we don't know. Let me say that the population standard deviation is 2.3 years. I'm just made that up. What it would say to me is if that were true, then the confidence interval would be between 25 and 27 years old. 95% of the folks would fall in that range. Now, I think what's more likely is the population standard deviation would be something more like 5.6. And then it's like, oh, okay, then it jumps to 23 to 23.5 to 29.2. If I change my sample size to 35 rather than 15, ooh, we just narrow back down again. So it gives you some sense of I mean, it's fairly straightforward to use. If you know what, in this case here, you're going to know your decision of the alpha, you know the mean is, you know the population standard deviation, you know the sample size. You put those things in, and it'll give you confidence intervals for you. Again, only put numbers in here. When you clear it at the end, if you want to clear it, you go through and put blanks in every one of these things. And we're back to normal, back to where before. Third one here. Jump now to confidence interval for t-tests. It looks just like the one for z-tests, except that, and I say this up here, sigma is unknown. You don't know the population standard deviation. You may know your sample. You will certainly know your sample standard deviation. Again, it's the same piece here. You put in what your alpha is, 0.05. We'll put in 26.4 again. Standard deviation 3.2. I don't know. I'm making that up. And sample size of 15. What's wrong? This is equal to C2 divided by 2. Huh. Confidence interval. Why isn't this working? That's interesting. I don't know why this is not working. I'm not going to stay online with you here while I'm doing this. First of all, that should never come up. 1 minus alpha. Oh, here's the problem. I put in 5 for the alpha. It can't have a 5. It could be a 0.05. Let's do that. Oh, okay, there we go. And then it gives me a confidence interval here of 24 to 28. Those are the 3 tests. And again, there are 2 tests for comparing means, the t-test and the z-test. If you do not know sigma, the population standard deviation, then you have to use the t-test. If you do know sigma, the population standard deviation, then you can use a z-test. And what you get out of this are confidence intervals. That's the brief kind of a quick and dirty of how to use those 3 worksheets. And I think they are so much simpler because they'll give you a confidence interval, and you can decide if for instance, I give you a problem where I say, I think there's a clam problem I would do this on, where I'd say, they've done some research on clams on this island, and the average size of a clam is 5 inches with a standard deviation of 1.2 inches. Those would be the populations. You go out, you can collect 12 clams, and the average size of yours is 4 inches. So you could put the population mean and the population standard deviation into a z-test, and it would give you a confidence interval. And then you can look at what you've actually found and discover it's outside my confidence interval. That makes it statistically significant because there's less than a 5% chance that kind of variation would happen by chance alone. That's the point of doing these types of tests. That's one of the ways of thinking about how to use them effectively. Okay, let's stop there.